Hello students, this is my sixth lecture for the Unit 7 Transducer. In the previous 5 lecture, we discussed various types of transducer. And here in those lectures, we learn how we measure various types of quantity like displacement, pressure, force with the help of various transducer. In this series, till now we discussed piezoelectric transducer, piezoresistive transducer, uh, piezoresistive, piezoinductive, and piezocapacitive transducer, strain gauge, LVDT, and various other transducer. Now, my next topic is flow measurement. How we measure flow of a liquid with the help of transducer. There are two type of devices. Yeah, you can say transducer with the help of which we measure flow of a liquid. This is mechanical and electrical transducer. In mechanical transducer, we use orifice plate, Venturi tube, rotameter, vanes, and in electrical transducer, we have hot wire anemometer, thermistor flow meter, turbine flow meter, electromagnetic flow meter, ultrasonic flow meter. Now, in our uh, syllabus, we have only electromagnetic flow meter, ultrasonic flow meter, laser, and thermal flow meter. But we have little discussion about these mechanical transducer also. Now, what is the basic principle of these mechanical transducer? The basic principle is if any obstruction is placed in the path of a liquid, then the pressure difference occurs before and after the object. This pressure difference is function of liquid flow rate. This principle is used in orifice, Venturi plate, and rotameter mechanical devices to measure the flow. These orifice and Venturi tube are used for the large flow like canal, dams, reverse flow, and rotameter generally used in laboratory purpose. So these are shown here. Now our main aim is electrical transducer. Electrical transducer, we have hot wire anemometer. In hot wire anemometer, we have a chamber where the liquid will flow, and we have a hot wire resistance. When liquid flow will pass through this hot wire resistor, there will be change in the resistance, and this change in resistance will unbalance this breeze, and as a result we got output voltage, and we calibrated this output voltage in terms of liquid flow. This is the basic principle of electrical transducer. In the previous transducer, we also discussed that change in resistance, with the help of measuring the change in resistance, we can measure various quantity like temperature, pressure, and hot wire anemometer. In hot wire anemometer, we measured flow with the help of that change in resistance. Here, this hot wire is made up of tungsten and platinum, and this you can see this is a bridge type structure, and this is a chamber where liquid will pass. This liquid, when this liquid will be in contact with the hot wire resistance, there will be change in resistance, because this liquid will when this liquid will flow, it will decrease the temperature or may increase the temperature. Due to this, there will be change in resistance. Now here it is mentioned here, if liquid is flowing over a heated surface, the surface temperature is changed due to absorption of the heat by the liquid. This causes change in the resistance of the hot wire. The hot wire is made up of tungsten and platinum. In presence of liquid, resistance will change and causing unbalance in bridge circuit. Output voltage is calibrated in terms of liquid flow. It is mostly used in industry for measurement for both static and dynamic liquid flow. As I have already told you, I explained this working. Now you can it can be easily understandable to you. Now thermistor flow meter. The structure is same like hot wire anemometer. There we are using hot wire anemometer, and here we will use thermistor, and we used another dummy thermistor which is used as compensator of this main thermistor. The liquid will flow through this thermistor, and there will be change in resistance, due to which this bridge will be unbalanced. As a result, there will be change in voltage, and this change in voltage can be measured in terms of liquid flow. So thermistor flow the meter is used up to 10 raised to power minus 3 meter per second. And there is here we have some specification for this thermistor flow meter. It has high sensitivity. It has self-heating effect. The thermistor measures both static and dynamic liquid flow. ठीक है? A dummy thermistor is used for compensation of atmospheric temperature changes. Now, next is turbine flow meter. In turbine flow meter, we have turbine-like structure like blade. When liquid will flow, that turbine will rotate, and this rotation is converted into electrical signal through the pickup coil, which will be generated as pulses, and this will, with the help of these pulses, V naught is calculated. V naught is generated. V naught means output voltage. Now this principle is used in petrol pump. We have petrol pump nozzle. That nozzle will shows using this type of transducer. This is the structure of our turbine flow meter. If liquid flow is 0, then turbine will not rotate, no change of the flux. If liquid will flow, there will be rotation of turbines. As a result, there will be change in magnetic flux, and there will be a induced EMF in the coil, which will generate pulses, and this pulses is connected to a digital counter which count these pulses, and with the help of these pulses we can calculate voltage. In the presence of liquid, the turbine will rotate, causing rate of change of flux of the permanent magnet. This will induce EMF in the pickup coil in form of pulses. These pulses are applied to a digital counter displayed in 7-segment display. Application used to measure low viscosity and high velocity liquid flow like petrochemical industry. Now, electromagnetic flow meter. This is the structure of a electromagnetic flow meter. Here we have north and south pole which generate some constant magnetic field. This is a pipe through which our liquid will pass. When the liquid will pass through these pipes, there will be change in flux, and this flux will change in flux will produce output voltage, and this output voltage is calibrated in terms of flow. This is the basic working principle of electromagnetic flow meter. Let's read out. It is used for high viscous and low velocity liquids, for only electrical conducting liquids, and this is the disadvantage of electromagnetic flow meter. This can be used only for electrical conducting liquids. If an electrically conducting liquid having a charge of Q moving velocity v in a magnetic field, an EMF is induced across the electrodes, which is the function of velocity of a liquid. This is our electromagnetic flow meter. Now, next is temperature measurement. How we measure temperature with the help of transducer. There are two types of temperature measurement. One is contact, second one is non-contact. In contact, we have RTD, thermistor, thermocouple, bimetallic strip, and in non-contact, we have pyrometer. Here in our syllabus, we have only thermistor and thermocouple. So now I have described here RTD, thermistor, thermocouple, bimetallic, both, all four, but thermocouple is in our syllabus, so we will directly discuss thermocouple. As in the previous lecture we discussed, if we have two metals M1 and M2, when these metals are contacted, there will be a junction forms which will generate potential voltage across the junction. As a result, there will be current will flow, and this can be measured. This change in voltage can be measured in terms of temperature. Now this shows the non-linear expression of thermocouple. Here T1 is hot junction temperature and T2 is cold reference junction transistor. One is positive metal, second one is negative metal. There are various types of metal which are used as positive and negative metal. This is the list for positive and negative metal. and this is the voltage swing for these metals, and what types of connecting wire we use these metals are shown in this table. Please go through this, and this table is very important for objective point of view. And here we are, this shows the composition of various metals which are used for the connecting wires, that is constantan, chromat, aluminate, platinum, and RH. It is high sensitive E type and temperature range is B type. Then thermocouple works on the principle of Seebeck effect. Type B thermocouple measure highest temperature up to 1800 degrees Celsius. It produces very low output voltage, so that sensitivity is very high. Sensitivity is very small and stability is very high over wide range of temperature. Type E has higher sensitivity because it provides more output voltage for reducing the cost of the measuring system. The thermocouple metals are terminated with the lead wires because the cost of lead wire is less, and application of thermocouples are used for measurement of higher temperature and electrical bottles of higher capacity, and in nuclear power station